welcome back. Today we're going to go over an exercise where we're going to use the geometry to come up with the values of certain definite integrals. And we're given the graph of the function f. F is defined piecewise because on each subinterval the behavior of the function is different. And we are asked to find the integrals of f on different subintervals. To achieve this goal, we're going to try to match each definite integral to the areas between the f function and the x-axis. Before we start, I want to make a few remarks here. So let's say like if you're talking about this area here between the blue curve and the x-axis, well, this area can be represented by a definite integral, but in particular the function value is positive here. So if you look at the area, that area is exactly equal to the integral of this function over the subinterval. But what happens if the function takes the negative values, like on this interval here, or on this subinterval here, -6 and -4? So in that case, we can still represent a definite integral of the function by using the area concept. So all we're going to do here is that we're going to find the area here by using geometry, and we're going to take the negative of that. So the negative version of the area is the value of the integral of f on that subinterval. So we have to pay attention, you know, if the function takes the positive values or negative values over certain intervals. So let's start with the first one. So the first one is asking us to find the definite integral of f from -6 to -4. All right, so this is a triangular region. And in fact, we know how to find the area of a triangle. This is the base times height of the triangle divided by 2. So I can go ahead and write here that, you know, this is going to be exactly equal to the area. But since the values of f is negative, so I should multiply that by -1. So in other words, -1 times, or negative of the area of the triangle here. So let's just find the lengths of each side, base and height. So, well, this is from -6 to -4, so the base is going to be of length 2 times the height. Well, this is height is -2 as well, right? So the length from here to here is just 2. So lengths can only be positive, right? And then we'll take the 1/2 of that. That's the area of the triangle, right? So 1/2 base times height divided by 2, but multiplied by -1 because the function values are negative here. So this will yield exactly -2. All right, let's see what we can do for part B. Part B is the integral from -4 to -2. Okay, we can still represent this by the area between the blue curve and the x-axis, but the function takes negative values here, so we're going to put a negative sign here, and we're going to try to find the area of the half circle. So this is the half circle. Okay, we know the area of the circle, which is pi times r squared. So we're gonna get the half of that. So 1/2 times pi times r squared. So all we need to know is the radius, because r is the radius of the circle. So if you think that the center is located right here, right? Because this is almost like full circle here, right? So then the radius is going to be what? From this point to here, or from this point to here, that's just 1. So the radius of the circle is just 1. So essentially this is pi times 1 squared, but this is equal to -pi/2. Let's look at what's going on in part C. In part C, you're asked to find a definite integral from -6 to -2. Okay, -6 all the way to -2. And for this case, we can just get the sum of the areas and multiply by -1. Or we can use one of the properties listed in this lecture notes. In fact, it is integral from -6 to -2 of a function can be split into 2. You can first look at the integral from -6 to -4, f of x dx, and then you can add it to the integral from -4 to -2, f of x dx. Okay? So this in fact comes out of part A, this in fact comes out of part B, so we're just going to add these two numbers, so it's going to be -2 minus pi/2. all right? Or you can just use the same idea I just told you. So negative of the sum of the areas, the triangle and the half circle, would be the answer. All right, in part D, we are asked to find the integral of f from 2 to 4. On the interval 2 and 4, as you see that the function takes the value of 0. So in other words, there's no area to talk about because you can think that as a rectangle like the way here, right? So the area of the rectangle is the base times the height of that. Well, we have the base of the rectangle, but the height is 0, so 0 times the base would be just 0. Or in other words, there's no area to talk about, so this is exactly equal to 0. In part E, we have the integral from 1 to 2 of f of x dx. Let's check what's going on the interval 1 and 2. So here we go, 1 and 2 here. So, well, the function takes a negative value, so I go ahead and then write or put the negative sign here. And all I'm going to do is to calculate the area of this triangle, right triangle here, right? So the area of that is base times the height of the triangle divided by 2. So base is of length 1, I think, right here. Base is of length 1. Height is of length 1. So in other words, 1/2 times 1 times 1 is the area of the triangle. But we take the negative of that, so that integral in part E is equal to negative 1/2. All right, let's go to part F. I think I had a typo here, so I meant here that we were asked to find the integral from -6 to 6. So why don't you correct this? So I am asking the integral from -6 to 6 of f of x dx. So then I gotta find all the areas first, and then depending on the sign of f on the corresponding subintervals, I should take the negative of those areas. Okay, so let's just do it on the graph. So here's a triangle. We found the area of this by base times height divided by 2. So 2 times 2 divided by 2. So the area is 2. Okay. For this one, I think we got it as 1/2 pi. So it's 1/2 pi r squared because it's the half circle and r is 1. And for this one, let's see, the base is 2, from -2 to 0, that's 2. And the height is 3, so 3 times 2 is the area of the rectangle, so this is 6, okay. And we just came up with the area of this one as 1/2, right? So 1/2, but these are twins, same base, same height, so this would be 1/2. So which ones are negative, which ones are positive? And there's no area, by the way, here, so the area is 0. And let's decide which ones are negative. So the ones below the x-axis are going to be negative. So here, part F here, you have -2, minus pi over 2, minus 1/2, and another minus 1/2. These are the ones, these are the areas below the x-axis. And you have only one area above x-axis, that's 6. Okay. So this sum, all the way, some of these numbers would be the value of the integral of f from -6 to 6. You can simplify this by using your TA84. All right, this ends the video. Thanks for watching. If you have any questions or comments, please put down, and I'll see you in another video. Bye.